Today's topic is Varactor Diode, which is a special purpose diode. It's also called Varicap, Rolled Cap or Tuning Diode. It uses the reverse bias characteristics of capacitance in which there is an inherent capacitance. So in reverse bias, the two P and N region sides act as the parallel plate of the capacitor, and in between depletion region acts as the dielectric in the capacitor. So at zero reverse bias voltage, the capacitance is maximum, and as the reverse bias voltage increases, the width of the depletion region increases. So when the width of the distance between the parallel plate increases in reverse bias. So as this increases, the capacitance value decreases in C equal to epsilon naught A by D. So the capacitance is maximum at zero reverse bias voltage, and capacitance reduces as we increase the reverse bias voltage. So the variation of capacitance is maximum and reverse voltage is zero. So for abrupt doping junction, where the doping is equal in P and N region, then we have the one hyper abrupt doping junction where the concentration of charge carriers is maximum in the center of the P and N, and in the sides the concentration reduces exponentially. So for the abrupt doping junction, the maximum the tuning ratio, which is the ratio of maximum to minimum capacitance value, is 4:1. So if the maximum capacitance is 100 picofarad, the minimum value is 25 picofarad, 100:25 or 4:1 for the abrupt doping junction, where the doping is uniform on both sides. In hyper abrupt doping junction, where the doping is concentrated in the center, the tuning ratio is 10:1. The maximum to minimum capacitance value is 10:1. So as the doping increases, the depletion layer width decreases and the capacitance value increases. So we are going to see the maximum ratings for a example Varactor diode MV209. Before that, this is the symbol of Varactor diode, and it is equivalent to a resistance RS in series to a capacitance CT. So for the MV209 diode, the diode capacitance temperature coefficient TCC rating tells it gives a change in the capacitance for every 1 degree Celsius rise in temperature. TCC rating for MV209 is 300 parts per million per degree Celsius. So for 1 degree Celsius increase in temperature, the capacitance value increases by 300 parts per million. So it is for MV209, the rated value capacitance value is 29 picofarad. So it is 0.0003 into 29 picofarad, which is 0.0087 picofarad. So for every 1 degree Celsius increase in temperature, the capacitance value changes by a very small value. Picofarad itself is 10 to the power minus 9. So the Varactor diode is relatively independent of the temperature. So to have 1 degree Celsius increase, it extends 115 degrees C to increase. Okay, so the next one is capacitor rating CT. The rating for MV209 is 26 to 30 picofarad and VR is 3 volt DC. Capacitance ratio, variation of change in capacitance to change in voltage. So capacitance value changes from 5 to 6.5 when voltage changes from 3 to 25 volt DC. Figure of merit, quality factor of capacitance. It's the ratio of energy stored in capacitance to energy lost through leakage current. It's the ratio of power returned to circuit by the capacitor to the power dissipated by the capacitor. For MV209, Q rating is 200. Figure of merit is Varactor diode applications. It can be used in tuning circuit, used in electronic tuners, in radio, TV and other commercial receivers. When Varactor diode is used in tuning circuits, allows a resonant frequency to be adjusted by a variable. So F naught equal to 1 by 2 pi root LC. So here we have two capacitances, C1 here and C2 here. So C is C1 C2 by C1 plus C2. C1 and C2 are maximum and minimum values of the capacitances. So Varactor diode is used in auto frequency control devices, just will band pass filter and parametric amplifiers. So this is regarding Varactor diode. Thank you.